Hello, welcome to our YouTube channel, Supermatics Online Math once again. Today's math video is an SAT question. A machine launches a softball from ground level, that's zero level in terms of height. The softball reaches a maximum height of 51.84 meters above the ground at 1.8 seconds and hit the ground at 3.6 seconds. Which equation represents the height above ground h in meters of the softball t seconds after it is launched? To get the equation, we are going to visualize the motion of the softball on a graph. The motion is a parabola. So first we have the vertical axis, which is the height axis, and we have the horizontal axis, which is the time axis. From the instruction, the maximum height reached happens to be 51.84 at 1.8 seconds. So the graph, the curve is something that looks like this. Where the maximum height, that's the maximum h value, 51.84. This height was reached in 1.8 seconds. So the value of t on the horizontal axis that corresponds to the maximum value is actually the axis of symmetry that divides the parabola into symmetrical parts. Don't forget, this is just a rough sketch. This happens when the time is 1.8 seconds. Then the ball reached the ground level at 3.6 seconds. The ground level is when the height is 0 on the x-axis. So we can say it is one of the x-intercepts. Information that we can take from this graph is that the vertex, the point of the vertex, which is actually the axis of symmetry for the t value on the horizontal axis, and the maximum or minimum, but maximum in this case for the h or vertical axis, 51.84. Also, we can get one additional point on the curve, and that's the ground level point given to us. This is 3.6 for T and 0 for H, being the ground level. How then do this apply to the equation of the motion of the ball? The vertex form of quadratic functions is generally given as y equals to a times the quantity x minus h to the second power plus k where hk is the vertex. In this situation, since we are dealing with height and time, we're going to express the vertex form as h equals to a times the quantity t minus n to the second power plus m, where the vertex in our case is n, m, and this, from what we visualized earlier, is 1.8 for n and 51.84 for m. We also have an additional point where t, the ground level point, where t is 3.6 and h is 0. We're going to substitute all these values into the vertex form here in order to get the value of the leading coefficient a, and thereafter obtain the equation. Plugging in these values, we have 0 equals to A times the quantity 3.6 minus 1.8 to the second power plus 51.84. This is 0 equals to A times 1.8, which is the difference between 3.6 and 1.8, and then squared plus 51.84. 0 is equal to, the square of 1.8 is 3.24, so we have 3.24a plus 51.84. We subtract 51.84 from both sides, giving us on the left hand side negative 51.84, and on the right it is 3.24a. Then we divide both sides by 3.24. A, the leading coefficient, as negative 16. So the value of A is plugged back into the vertex form in order to get the quadratic function that represents the motion of the softball. Plugging it back into this vertex form, we have the function as h equals to negative 16 times the quantity t minus 1.8 to the second power plus 51.84. The correct answer is in option D. And if you're yet to subscribe to our channel, please do so now and click on the notification bell so that you do not miss out on any updates from this channel. Till we see you again in our next math tutorial, we say bye.